For some reason I didn't hit record, so Haley gets to listen to some of this for the second time. Okay, so a quick wrap up. What we notice when we see this title here, okay, double bond, triple bond, there's no surprise there. So what does that mean? As opposed to your alkane counterparts, these are unsaturated. So somewhere there's going to be either a double or a triple bond. Imagine that, how much better this works when you actually hit record. And yet I can fail at that. Okay, so moving on. Okay, nature of the alkene. Yes, it's unsaturated. So at some point, like we just discussed, there's going to be some form of multiple bonding in there, whether it is a double or a triple bond. The alkyne formula is just a little different. Okay. There is some similarities to that of the alkanes. Okay. The naming, that would be no different if you're talking about octene. Okay. That just means there's a double bond after the first carbon, and you'd still have the formula of C8H16 then, as opposed to C8H18 for its alkane counterpart as octane instead of octene. And also, there's a similarity here. The first three gases are also that of, the first three are gases, okay? Whether you're talking about that of methane, ethane, and propane, we know are all gases, okay? But in this case, is this something I didn't ask earlier? What is the simplest alkene? Because what's the simplest alkane? Natural gas, which is also, that's the common name. What's the scientific name for natural gas? How many carbons in length? What would that be called? You're going to hit yourself in the head and you're going to say, I knew that. What's 2 carbons? 3 carbons? Propane, so back up 1. What's a 2 carbon derivative? Methyl and ethyl. So those are your derivatives. So what are they derived from? Yeah, true. But the methyl comes from what name? Natural gas, or it's an alkane. Methane, and then ethyl comes from ethane. Yep, those are your first 3. Now, what is this is one I didn't ask earlier, what is the simplest alkene though? Do you suppose there's such a thing as methane? No, there cannot, because there has to be a carbon-to-carbon double bond. But if it's methane, there's only 1 carbon to begin with. So you can't have an unsaturated single carbon alkene. It just doesn't work that way. So in this case, your first 3 are gases: ethene, propene, and butene. Okay, that's once you get to pentene, then they are liquids in that case. Okay, so there are some similarities. Okay, this is just slightly different. Okay, the naming's similar, the formula is different, and then of course these are unsaturated as opposed to their alkane counterparts. Okay, and these are also insoluble in water. One of the aspects that we were talking about, that I was, but I didn't have it recording, and that is back when all these compounds were being discovered, that some of them are, let's say, boiled and then distilled. You know, when we say boiled, that just means they're starting to separate out at different temperatures. Whether it's, I believe, you could say diesel fuel is somewhere around 10 carbons. Kerosene, I believe, is 9 carbons, and of course octane is 8. Heptane would be that of 7. And none of these would mix with water. So when this kerosene was being burned, as far as that of lighting for inside houses, well, once electricity was discovered, well, excuse me, what are we going to do with this kerosene now? And octane as well. Well, at that point, the internal combustion engine was just making its appearance, so then there was actual uses for those components. And now we had drawn this up on the board on Friday, okay? And this is one of them aspects where if you were to look at what you wrote down, if you had chose to do this, I probably told you there's no need for that, but one of the aspects that what we would say is look at what you wrote down and then read once what it says, okay? It occurs because of only one type of connectivity for alkanes. It's all single bonded, okay? That's what that's referring to. Other families possesses two. So in this case, when we're talking about butene instead, okay, when you look at butane, we had established it's C4H10. Then there's only 2-methylpropane. There's only 2 structures for that, okay? But then when you look at butene, however, you count that as 1. Then we said you can have 2 butene and then 2-methyl 2-propene, okay? So there's 3 structures associated with this one where alkanes only have, in this case, 2, okay? But as the number increases, so does the number of isomers. And the reason for that is you can always move your methyl groups around and also your double bond. When we just say butene, it's just understood that that double bond is after the first carbon. Okay, we just wanted a brief introduction to this, so I'm presuming we'll catch up with you all tomorrow. And then that's at that point we'll start talking about some of the naming that we would be associated with this. All right, so we'll catch up to you next time.